I will try to show you the XCP module of the COSIM seal simulation. This driver is enabled from COSIM 2.3 and you can connect using the XCP master to the seal simulation and try to calibrate your simulation and read the data from the simulation back using the tools which support the XCP master and XCP protocol. One of the tools that supports in the ETAS world is the Inca, and we're gonna show this demo using both Inca and COSIM in parallel how we can actually make this happen. So let's start. I already created a project and I loaded some of my models inside this project. So first thing you need to do is to add a system. So we create a new system and we call it XCP system, for example. Create it. When you create a system, you need to define a target for this system. We go to the change target, by default is none. We're gonna add the seal target. As I told you, the XCP module gonna work on the seal target. So I save it. Now I will add my models. I'm gonna add two models in here. One is the Simulink model and one other is a C model. After adding the models inside your system and configuring your import and output, we need to configure the sorry, we need to configure the rasters of our system and models. First of all, I save it. I don't need any connection in here. I'm going to the deployment view, and in here I'm gonna assign the different rasters and tasks to my functions of the models. To doing that, I'm gonna use the auto mapping feature of COSIM. After this, as you can see, the two tasks is added. One is 2.5 millisecond and the other one is 5 millisecond raster. The next step after your deployment view is finished and you add all of your tasks that you need, we have to go to the properties tab. It's going to ask, do you want to save? I'm going to save. In the properties tab, we have this XCP connection option. I'm going to enable it. And in advanced setting, I can select the different data channels. Okay, this is a little bit need the knowledge of the XCP or Inca tool. So in here, we can define different data channels and we're going to define this data channel going to work in which raster. For example, by default, COSIM going to enable you the fastest task, for example, 2.5 millisecond. And this task is assigned to data channel 1. I can assign a task to another channel myself, for example, 5 millisecond to data channel 2. This DAC means data acquisition. And 3, 4, 5, I don't have any other task, but still I can assign the same task to different data channels. So in the Inca world, this channel is going to be called events. And because of that, we have the event 1, 2, 3, 4, 5. And in the XCP world, this is going to be called data acquisition channel. And in here, we have data acquisition 1, 2, 3, 4, 5. After this is finished, we're going to go to the XCP config. Okay, to save. So Inca gonna connect using the XCP protocol, as I said, to the simulation, for example, or any other XCP master like Inca. To connect to the XCP protocol, the XCP slave inside the simulation support both TCP or UDP protocol, and user can select any of them that he wants. So for now, I kept this TCP as the default. You can change the port for example, in here, and you can this port number gonna start from 5555, and you can increase the port number to any number that you want. You can change the session name as well in here. I'm just gonna keep it like this, but you can add different sessions too. For example, if you want to have different A12 files for your different models. So A12 files, I'm going to explain it a little bit. What is the A12 file? A12 file contains all of the data that you want to calibrate and read from your XCP master tool, from your Inca tool. For example, you can define different A12 files containing different models with different sessions, and then load this A12 file just for that specific model, or you can have a A12 file with all models and load just one A12 file inside your XCP, inside your Inca, and work on that. Okay, let's create an A12 file. I'm gonna call this my A12, and I'm gonna assign this to session 1, for example. Each A12 file just can have one session, and this is the restriction that this protocol has. So I add this A12 file, I add the model first model and then the second model to my A12 file, and we are done. So from the cosine part, we configured our system, we enabled the XCP system, we defined our A12 file, which calibration variable and measurements it should contain, and then we build the project. It's going to take a little time to generate the code for the models and bring up and generate the A12 files. So it finished successfully. I'm going to run it. This is a very important part. When we run this, it's going to bring up the command EE for us. Command EE is a tool that we're going to use to download and start the simulation. Let's go back to the here. After you generate your A12 file, you can export your A12 file to any location you want. For example, I'm going to put it inside my drive B, overwrite it if it exists. And now I'm gonna go to the Inca tool. So in Inca tool, it's in the database workspace. If you right click, you have this add and the ECU project A12 file. You can see in here, you're gonna select this and then select the A12 file that you already generated. For example, my A12 file. Inca gonna ask you if you have any hex file that contains some data for this A12 file. For example, in this A12 file, as I told you, we generate the calibration variable and measurement variable, and the hex file gonna have some data regarding this, but I don't have any hex file, so I cancel this. The second step in Inca is to create a workspace. So in here, I right click again, add workspace. You can change the name of the workspace, of course. Each workspace can have different devices. I'm going to add one device in here, and that device is my A12 file. This A12 file is a very special A12 file because it contains the XCP configuration, and the Inca gonna understand this A12 file is actually contains an XCP device. So when I OK this, the Inca automatically bring up this for me. So it understands this is have an XCP A12 file, and it support the Ethernet system and the TCP. And you have two options in here: XCP with support of the simulation time and the XCP for the real systems. Because we are working on the simulation, we are going to select the XCP sim time in here, and then we're going to OK. You can see the warnings and errors in here. There is no warning and error. Inca is loaded the A12 file. I'm gonna go to the configure hardware part. When you select the configure hardware, you can see the defined port in here, defined TCP IP in here, and the other default values that we are setting when we generate our A12 file. Okay, from here, if you try to connect to this device using this button, initialize hardware, it's not gonna work. And the reason is we didn't download the simulation. So in the simulation world, whenever you create and generate a simulation, specifically in the COSIM, you need to first download and then start the simulation to be enabled to see the simulation. And because of that, we need the command E. As you remember, we run let me show this again. from the COSIM, there is a run button in here, build and run. It's not gonna build again because it's already built. So it's gonna run the command EE for us. From the command EE, we can download our simulation. And download means brings up our simulation in the initial states. So I'm gonna download it. The seal simulation gonna work in background. I go into Inca device. I try to initialize, and Inca automatically connect to the sys simulation as you see, and it's gonna bring up for you this upload form. So what is the upload? Upload means read the data from the simulation for the first time. So in the A12 file, we have defined so many variables for the Inca, and when we upload, it's gonna ask you, this is not a real ECU. You're gonna say, yes, I know that. It's gonna ask you where you want to save the upload data. I don't want to save any specific place, so no. And then Inca load all of the data. You need to close this yourself, and then you can go to the experiment environment. So in here, if the ECU is not connected, you're gonna see this. If there is some checksum error, you're gonna see the error as well. But there is no error, so it means for now everything is working. I go to the select variable. I'm gonna select two map file, one map from my C module and one map from my Simulink module. These namings that you see in here is already defined in the parameter file of these models. These models already define these parameters based on these names, and we keep the same names in here. So in Inca, you're gonna see this parameter names that we already have inside the COSIM as well. So S mode in here means Simulink model, C mode in here based on our model names is our C module. These two variables are calibration variables, and I'm gonna select them. Okay, this one is a really big map. As you can see, it has, I think, more than 2,000 variables. This is the map from the Simulink model. And we have a small map. This is a map from the C model. And it contains just, 3 multiplied by 5 variables. So let's test this feature. So we already downloaded the simulation, we loaded the simulation, but we didn't start the simulation. But still, you can write the parameter. So you can change the value in here, and it's gonna apply to this simulation. So let's start the simulation and check the parameters if it's working on the applying to the command E as well or not. So I start the simulation. I'm gonna select one variable here. So for example, let's try another variable. I'm gonna select an array data type from the calibration variable. Array data type. It's easier to follow an array. Yep, in here. As you can see, the values inside this array, 10 elements, and the values are this. Let's see the same value inside the Inca. So I go to the variables again. I select the array filter and PA double C module. And you can see 1.1, 2.2, 3.3 is the same as exactly as common E version. So in Inca, graphically, you can change the values as well. For example, I can change it like this. And you're going to see the result in here for the variable 2 is changed. So I'm going to add it like this, 3. And if I come here, it's already 3. And it's applying the command E as well. So this was regarding the calibration part. So we can calibrate different data types. My models have all of the data types that the Inca supports and the Common E supports. For example, I can show you a curve. This is a curve. I'm going to select this curve and this curve, for example, and you can see curve is a simple 2 array, and it's going to show you a function type curve. And you can change all of the value in here, and you're going to see it. It's going to apply to the simulation. We are running the simulation, and this value is already applying. Even you can change the index, for example, 11. So this is possible as well. Now you can select the variable by based on the axis, because each curve has an axis, so you can change the axis from here as well. This is another data type, and I can change the axis in here to 12, for example. And you can see the value is changing in here too. The reason we didn't see the first change from here to here was that this wasn't uploaded by the Inca yet. The calibration works in offline mode in Inca. What that means, it means it's if you open the UIs in this both, it's gonna be connected to each other, and if you change it here, it's gonna change in here. But if you don't do it, it's not gonna understand if something is changing here in here. And to test this again, I can show you another curve. Let's start with double curve begin here. Oh, this is very big curve. Let's go to the first one. This is starting from 0.01. I'm going to make it 0.015. For example, if I open again from the variables, the double axis of this big curve, sorry, axis of this big curve, it is still showing the 0.01. How can I be sure this is right to the system? I can upload the data again, because as I told you, calibration works in the just one way. It doesn't update from the simulation. Just the UI is updated from the Inca part, and you can see it's updated. So it's just want to show that that wasn't a bug. Okay, let's go to the data acquisition and data channel. So we saw the calibration part happening both in the Common E and Inca. If you change something in here, in Inca, after upload, you can see the changes for the calibration variables. But for measurements, we need to define, the workflow is a little different. First of all, let's try one variable. For example, you can select an array, and I'm going to select the last event for this array. I want to read all of the values. Sorry, my shift doesn't work in here. So this one until this one. Now select, okay. Nope, yep. And I'm gonna select yes, event 3 for this one, event 4 for this one. And if you remember, event 4 was in every 5 milliseconds. So event 4 is 5% is already full, because in the XCP protocol you can just have 255 variables in one event. 5% of this event is full. I'm gonna select another variable, timer dynamic, for example, and I'm gonna put it in event 2 or 3, sorry, and then okay. So Inca gonna add all of the variables. This is the time one, and this is the array one. And I'm gonna start my event. This means Inca gonna send one request to the simulation that please start the data acquisition channels. And this data acquisition channels work as a measure rate of event 3, and if you remember, event 3 was 5 milliseconds. If I go to the Common E at the same value, for all object data type. This is a scalar value. You can see this value is changing here as well, and here as well. And if you check it, it's actually working fine, and both of them actually working with the same way. So it's gonna go to some number and then start from 0. And you can stop the simulation and stop the data channel in here. First of all, it's gonna stop the data channel, and then I'm gonna stop my simulation in here, and it's done.